Okay, now let's have a quick review. Now, I would say this piece of paper would be like a little mirror. You know how to fill out the details of this table? You're good to go on Monday. If you have trouble filling in the details of this paper, then make sure you can do it over the weekend. Now, do not cramp these the night before, the day off, the period before the quiz. Okay. If you're gonna spend 30 minutes to cramp, I would suggest you to spend 10 minutes on each day. That would have a long-lasting effect of your memory. Now, and things that we have done for some time already. I mean, we had a quiz on circles and ellipses, right? So you know we have a center, and we have a center that's known as h comma k. Okay. Now the key right here is, can you produce the information here without being prompted? Okay. Can you produce the information without being prompted? Can you write down the equation? Okay, and you can tell what the equations are for. You know the R stands for the radius. Okay, you know that in the general form. Now, by the way, this x squared and y squared I meant for the general form. You would know that, oh yeah, if you look at the general form, the equation of the general form, the coefficient of the x squared and y squared would be the same. And that's how you can tell at a quick glance, with a quick glance, that what shape it is without the standard form right in front of you. Okay, there's no A, B, and C for circle, so you don't have to write anything. If you write down anything, that would be weird because there's no A, B at all in the standard form. There's no latus rectum because there's no focus. And what's the eccentricity of a circle? 0, right? Okay. Now, the final column on the right, notes, remarks, it's just something if there's any additional detail that we didn't write down and we need extra space to write it, then we'll put it here. But for circle, I think we're good. I think we're good. Okay. And if you want, you can label the radius, but I guess you should know what radius is by now. And then we have horizontal ellipse. Okay. With the center, h comma k. What's the A value for? On the major axis, right? From the center to the endpoint. That's your A, and this is your B, okay? And of course, you have your foci, okay? So if you can draw the diagram by not copying me and write down everything that's supposed to, that would be fantastic, right? So and if you draw the vertical ellipse, right, you still have a center, you still have the major axis. Okay, so this is your A, this is your B. Oh, didn't label the C. Well, this is the C because it's the distance from the center to the focus. So this is the focus, then our C value would be here. All right, with the equations, we have fractions. To go to 1, we said that it's x minus h square, y minus k square, and a square and b square. Okay. And then the difference between horizontal and vertical ellipses. What's the difference in the equation? The denominator. So so a square would go to the y side because of the because it's vertically oriented. So and among A, B, and C, what do we know about A, B, and C? Well, we say C squared is equal to A squared minus B squared. And the easiest mistake is that people try to just memorize something, but then they memorize it wrong. So how can we tell ourselves that it has to be A squared minus B squared? Yeah, A is the longest. Like if you open your eyes, if you know how to label them, come on. A is the longest, so it got to be A squared minus B squared. For the coefficients, they are different. And what else? There's one more condition. They're different, but they're both having the same sign. Okay, well, so far we have seen positive, and they tend to be positive. Okay, if they're both negative, then we just divide it over. But yeah, so far they have to have the same sign, but they're different numbers. Okay, so same for this. How do we calculate the length of lattice rectum? 2b squared over a. Right, majority of people know it. I want all people to know it. I want everyone to come in here Monday. Yeah, it's easy. It's 2b squared over a. How do you calculate eccentricity? C over a. Right? So, yeah, it's not, maybe just do this. Okay? So, pretty straightforward. Okay? Horizontal, vertical ellipses. If you know how to write the equations, I think you're good. If you know how to complete the square, you are in perfect shape. All right. So, so if you know how to do it, then the next thing is about your efficiency. Now, for horizontal hyperbola, we have the center, right? We have the vertices that we're going to draw our graph. And also, don't forget, we have our box. Okay. And we should also know how to label the A and B. So this is B, okay? And the C, which is the focus, will be here. And therefore, this is your C, okay? All right, now when we draw our hyperbolas for this one and the next one, okay, we often, well, we need to draw the asymptotes. And we said it's very crucial that we know the slope of the asymptotes. So we say, all right, in this case, is it A over B or B over A for the asymptotes? What do you say? It's what? B over A because? Rise over run. Okay, if you label it, you cannot miss it. And you should not memorize it. You should get it from the diagram. Rise over run. Just open your eyes, label it, know it, rise over run, B over A. Okay? So that's the horizontal hyperbola. And for vertical, the one thing I hope you can get, it's like feel proud for yourself if you're able to obtain all the details for all these conic shapes. Okay, so for this one, so if you label your A and B again, this is A, and this is B. So the conic shape, it's plus or minus, oh, well, the asymptote in this case, the asymptote in this case would be rise over run, rise over run. That would be A over B. Okay, so all right, how is the standard form equation different from the ellipse equation? We say that's going to be a subtraction, right? It's going to be a subtraction, and A squared and B squared. Okay. And then what should be changed for the vertical hyperbola? The numerator has to be changed because it's vertical, so the y goes up front, the x goes second. A and b, they stay. Okay, they stay. And on the general form equation, they will be, well, the coefficients are different for x squared and y squared. Not only they are different, they must have opposite signs. Okay, so they are different and they must have opposite signs so that you can tell what they look like, what it is. And the relationship between A, B, and C is that a C squared in this case is equal to A squared plus B squared. Because, why is it a plus this time? Yeah, C is the longest. If you label a diagram, you know C is the longest. So if it has to be A squared plus B squared to get something longer than A. All right, so lattice rectum is still 2b squared over A. And eccentricity, it's still C over A. All right. And for the notes or remarks, I'm just gonna go ahead and write down the asymptote equation with a point slope form. Okay. And since we got the slope already, that should be pretty convenient to write down the equation of the point slope form, equation for the asymptotes. Okay. So I hope you're not relearning, I hope. But if you need to spend time to review this, make sure to do it early. Make sure to do it every single day. Okay, it's about your time investment. You invest 5 minutes, 10 minutes to draw all these equations and shapes, write down. Quickly check your own understanding. It works wonder. Okay.